So now let's apply the concepts that we've learned to solve some past questions. So number one, we are told that if M and N are two matrices defined by M is equals to this and N is equals to this, we should evaluate 2M minus 3N. So this is under the algebra of matrices, and the first thing we have to do is to find 2M, and to do that we multiply 2 by everything M. So 2M will be equals to, so let's write it out. So we have 2M. So 2M will be equals to what? Multiply 2 by everything that is within the cells of matrix 2. So 2 times 1 becomes 2. 2 times 3 becomes 6. 2 times 2 becomes 4. 2 times 4 becomes 8. 2 times 5 becomes 10. 2 times minus 1 becomes minus 2. 2 times minus 3 becomes minus 6. 2 times 2 becomes 4. And 2 times 0 becomes 0. So now we're finding 2M minus, then we have 3M, N. So multiply everything in matrix N by 3. So 3 times 1 becomes 3. 3 times minus 2 becomes minus 6. 3 times 3 becomes 9. 3 times 4 becomes 12. 3 times minus 1 becomes minus 3. 3 times 5 is 15. 3 times 2 is 6. 3 times minus 3 is minus 9. And 3 times minus 1 is minus 3. So what we have to do is just to subtract these two matrices together. So here now, for the first element now, we are just going to subtract corresponding cells. We have 2 minus 3. 2 minus 3 will give me minus 1. For the next one, I have 6 minus minus 6. Minus times minus is plus, so 6 plus 6 will give me 12. Here I have 4 minus 9. 4 minus 9 will give me minus 5. For the next row now, I have 8 minus 12, which will give me minus 4. I have 10 minus minus 3, which is the same thing as 10 plus 3, which will give me 13. I have minus 2 minus 15, which will give me what? Minus 17. And for the third row, I have minus 6 minus 6, which will give me minus 12. 4 minus minus 9, which is the same thing as 4 plus 9, which gives me 13. And 0 minus minus 3. Minus times minus is plus. So 0 minus minus 3 gives me 3. So this is the result. So which option corresponds to this matrix? And that is B, option B. So the correct answer to this question is option B. Now let's move on to the next question. Here we are told to find P and Q for which the product of this times this is equals to this. So the first thing we want to do is that we want to multiply these two matrices together. And if you remember, to multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. The number of columns here is what? 2. So this is a 2 by 2 matrix. We have 2 columns here. And why this is a 2 by 1 matrix? We have what? 2 rows and 1 column. So the number of columns in the first matrix, which is 2, is equal to the number of rows in the second matrix, which is 2. So now when we multiply these two matrices together, what is the result going to be? It's going to be this one matrix here times this. If you remember, it's going to be the number of rows in the first matrix by the number of columns in the second matrix. So the result is going to be a 2 by 1 matrix. So let's try to multiply this together. So writing it out, we have what? 2p and we have 3. Here we have 3 and we have minus 5q times 1 over 2. Or 1 and 2 rather, 1 over 2. So to multiply this, what would this result in? To get the first cell now, we multiply the first row by the first column, by the only column there. So we have what? 2p times 1 plus 3 times 2. And to find the second row, we multiply the second row here by the column here. So I have what? 3 times 1 plus what? Minus 5q times 2 plus minus 5q times 2. And what does that result in? So that becomes what? 2p plus 3 times 2 is 6. And here it becomes what? 3, then 5q times minus 5q times 2 give me minus 10q. So I'm told that the product of these two numbers, this and this, is equals to what? 14 and minus 17 is equals to 14 and minus 17. And what have we talked about in relation to equal matrix? We say that for two matrices to be equal, the corresponding cells in them must be equal. So this cell over here must be equal to what is here, and this cell over here must be equal to what is here. So we can equate those terms together. So we can write out that what? That this must be equal to this. So we have what? 2p plus 6 must be equal to 14. So 2p is equal to 14 minus 6, which is equal to 8. So p will be equal to 8 over 2, and that is equal to 4. Now we can also say that this must be equal to this. So we know that what? 3 minus 10q must be equal to minus 17. So minus 10q must be equal to minus 17 minus 3, which is the same thing as minus 20. So q is the same thing as minus 20 divided by minus 10, which is equal to 2. So the value of p and q respectively is going to be what? P comma q is going to be what? 4 comma 2. Value of p is 4 and the value of q is 2. And what option corresponds to that? Option B. So the correct answer is B. Now the third question we'll be looking at, we are told that the determinant of this matrix is equal to minus 12. We are now told to find the value of x. So what we have to do is just to find the determinant of this matrix. And remember, to find the determinant, we multiply the two diagonals and we subtract from each other. So here the determinant is going to be this times this minus x times 4, then minus the second diagonal in this case, which is going to be 12 times minus 1. And we are told that the result is what? Minus 12. So what would that be? Minus x times 4 gives me minus 4x. Then minus 12 times minus 1 gives me minus 12. Is equals to minus 12. So minus 4x minus times minus is what? Plus. So I have plus 12 is equals to minus 12. So I can bring this over here. So I have minus 4x is equals to minus 12 minus 12. So minus 4x is equals to minus 24. And if I divide both sides by minus 4, I have x being equals to what? 6. Minus cancel minus. 24 divided by 4 is 6. So the value of x is 6. And that corresponds to option A. So the correct answer is A, 6. So let's move on to the next question now. And here we are told that if p is equals to this, evaluate x if the determinant of p is minus 10. So this is similar to the previous example. So now to find the determinant, we multiply this diagonal and minus it for the multiplication of this diagonal. So that is going to be equals to what? So this diagonal is going to be x plus 3 times what? X minus 1. Then minus the other diagonal is going to be what? X plus 2 times x plus 1. And we are told that the determinant, this product, is equals to what? Minus 10. So x times x gives me x squared. X times minus 1 gives me minus x. 3 times x gives me 3x. And 3 times minus 1 gives me minus 3. Then minus x times x gives me x squared. X times plus x gives me plus x. 2 times x gives me plus 2x. And 2 times 1 gives me 2. And I'm told that this is equals to minus 10. So what do I have? I have x squared plus 2x minus x plus 3x plus 2x minus 3. Then minus into bracket x squared. Then x plus 2x gives me plus 3x. Then plus 2 is equals to minus 10. So if I expand the minus plus 2x minus 3, so this becomes minus x squared. Minus 1 times plus 3x gives me minus 3x. And minus times plus give me minus 2 is equals to minus 10. So x squared cancels minus x squared. So I'm left with 2x minus 3x. 2x minus 3x is what? Minus x. And minus 3 minus 2 gives me what? Minus 5. So minus x minus 5 is equals to minus 10. So minus x will be equals to what? Minus 10 plus 5. So I can write out that what? That minus x is equals to, what is minus 10 plus 5? That will be minus 5. And if I divide both sides by minus 1, I have what? My x value being equals to 5. So the correct option is option D. The value of x is 5. So now to the next question. I thought that given that I3 is a unit matrix of order 3, find the determinant of I3. So now I should mention, I don't think I mentioned it before, yes, that a unit matrix is the same thing as an identity matrix. And I thought that I3 is a unit matrix of order 3. So you have a what? 3 by 3 matrix. And we said that a unit matrix is a matrix in which the diagonal is 1 and all other cell is what? 0. So I have what? I3 is equals to what? So I have 1 0 0 0 1 0 and 0 0 1. So we are told to find the determinant of this. So to do this, recall I told you that you first put your sign here. So you have plus here, you have minus here, and you have plus here. So you what? Take the first element, which is 1 plus 1. And what am I going to be left with when I cancel out this and this? I'm going to be left with 1 0 0 and 1. Then the next element here is minus 0. And when I cancel out this and this, I'm going to be left with what? 0 0 0 and 1. And the last element is what? Plus 3 plus 0 rather, this 0 over here. And when I cancel out this and this, I'm going to be left with 0 and 1, 0 and 0. So that is 0 and 1, 0 and 0. So when I expand now, so this is because what? 1. And what I have here is 1 times 1, which is 1, and 0 times 0 is bracket 0. Now this is going to be minus 0 times anything that is determinant here is going to be 0, and this is plus 0 times anything that is determinant here is also going to be 0. So this results in what? 1 times 1, and that is equals to 1. So the determinant of this matrix is equals to 1, and the correct option is C. And there is one important conclusion that I must make from this, and it's important for you to know, and that is that the determinant of a unit matrix is always equals to 1. Either it is a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 4 matrix. Provided it is a unit matrix, the determinant is always 1. So assuming you knew this rule beforehand, that determinant of a unit matrix is equals to 1, once you see a question like this, you don't need to solve through this. You just know by default that since it's a unit matrix, that the determinant is going to be equals to 1. So you can just directly select option C. So on to the next question. So we are told to find matrix T if ST is equals to I, where S is equals to this and I is an identity matrix. And as I mentioned before, an identity matrix is the same thing as what? Is a unit matrix. So in this case, my identity matrix I is saying that having a 2 by 2 unit matrix, which is 1 0 0 and 1. So I'm told that the product of S times T is equals to I. So let me write, and I'm told to find T. So I have what? ST is equals to I. So if I bring this S to the other side, I'm going to have my T is going to be my inverse of S times I. So now all I have to do now is to find the inverse of this matrix S. So now to find the inverse, I know that the inverse of S is equals to 1 over the determinant of S times the adjoint of S. So now the determinant of S, I can find that by just multiplying this and subtracting the multiplication of this. So I have minus 1 times minus 2, which gives me 2 minus, and I have 1 times 1, which gives me 1. So the determinant is what? Is 1. Now the adjoint of S will just be equals to what? I will turn around this diagonal over here. So I have what? Minus 2 and minus 1 over here. And I will leave here as it is. So I have what? 1 and 1. But I will change the polarity. So I'm going to include minus. So this is the adjoint of S. So the inverse of S now is just going to be the 1 over determinant, which is 1 over 1 times the adjoint, which is minus 2 minus 1, minus 1, and minus 1. So now I can find the value of t. The value of t is what? The inverse of S times my identity matrix. And the inverse of S I found out to be what? Minus 2, minus 1, minus 1, minus 1 times my identity matrix, which is what? 1, 0, 0, and 1. So I need to find this multiplication. So now let's quickly do that. So as I know, this is a 2 by 2 matrix and this is also a 2 by 2 matrix. The number of columns in the first matrix is equal to the number of rows in the second matrix, so I can multiply this, and the resulting matrix is going to be a 2 by 2 because I have 2 rows in the first matrix and I have 2 columns. So the resulting matrix is going to be a 2 by 2 matrix. So let's try to evaluate that. So what is that going to be? The product of this. So the first cell, I'm going to multiply the first row by the first column. So I have what? Minus 2 times 1, then plus minus 1 times 0. Then the second cell over here, I'm going to multiply the first row by the second column. So I'm going to have what? Minus 2 times 0, then plus minus 1 times 1. Now for the cell over here, let me put this in a bigger square bracket. So now for the cell over here, I'm going to multiply the second row by the first column. And what would that be? Minus 1 times 1 plus minus 1 times 0. As you can see, minus 1 times 1 plus minus 1 times 0. And for the last cell over here, I'm going to multiply the second row by the second column. So I'm going to have what? Minus 1 times 0 plus minus 1 times 1. So I have minus 1 times 0 plus minus 1 times 1. And what would that result in when I evaluate everything? So I'm going to have minus 2 times 1, which is minus 2. Minus 1 times 0 is 0. Yeah, I'm going to have minus 2 times 0 is 0. And minus 1 times 1 is minus 1. I'm going to have minus 1 times minus 1, which is minus 1. And minus 1 times 0 is 0. I'm going to have minus 1 times 0 is 0. And minus 1 times 1 is minus 1. And what would that be? So I have the value of t now to be equals to, I'm going to have minus 2 here, minus 1 here, minus 1 here, and minus 1. So the value of t is minus 2, minus 1, minus 1, and minus 1. So the answer to this question is option B. Another way of saying this is if I multiply t, this matrix S, by t, I'm going to get this identity matrix. So let's move on to the next question we'll be tackling. So here we are told to find the inverse of matrix N. So this is very straightforward. So we know that the inverse of matrix N is equals to 1 over the determinant times what? Determinant of N times the adjoint of N. Now to find the determinant of N, what are we going to do? That is pretty straightforward. So determinant of N is given as what? 4 times 2, given as 4 times 2 minus 1 times 3. And that will be equals to what? 8 minus 3, and that is equals to 5. Now the adjoint of N will be equals to, you change the first diagonal, you bring this here and you bring this here. So how about 4 and 2? While you leave the remaining as they are, 3 and 1, but you change the polarity. So since I have plus 3, I change to minus 3. I say if I have plus 1, I change to minus 1. So now the inverse of N just because to the 1 over determinant, which is 1 over 5, times the adjoint, which I've got it to be 4 minus 3 minus 1 and 2. And which option corresponds to this? That will be option B. So the inverse of this matrix is option B. 1 over 5 into bracket 4 minus 3 minus 1 and 2. So now let's look at the last example that we'll be considering. And here we are told to find y. And as you can see, this is a simultaneous equation in which we are told to use matrix to solve. So to start, I'm going to start by writing out what we had there. So we had that what? We had that A W is equals to what? Z. So now I'm trying to find the value of W. I will mention that W will be equals to what? The inverse of A times Z. So we know that what this is our matrix A here. So how do I find the inverse of A? So the inverse of A, as we know, is equals to 1 over the determinant of A times the adjoint of A. And we know that the determinant of A now will just be equals to what? Minus 7 times 5, then minus 2 times minus 6. And what would that be? Minus 7 times 5 gives me minus 35, then minus 2 times minus 6 gives me what? Minus 12. So I have minus 12. So I'm left with what? I'm left with minus 35 plus 12. And what does that result in? That results in what? 23 minus 23. So the determinant of matrix A is what? Is minus 23. So now let's move on. So here now, we are now told to find the value of the adjoint of A. So I know that the adjoint of A is pretty straightforward. I can find the adjoint of A. So the adjoint of A will just be equals to, I just reverse this. So I have what? Minus 7 and 2. And I write this as they are, but I change the polarity. So since I have minus 6 here is going to become a 6. And since I have a 2 here is going to become minus 2. So this is the adjoint of A. So the inverse of A is just going to be 1 over the determinant of A, which is 1 over minus 23, then times what? The adjoint of A, which is minus 7, 6, minus 2, and so this is a mistake. Here it's supposed to be a 5 when I turn the diagonal around. Minus 2 and 5. So when I bring this inside, this is okay. So this is going to be the inverse of A. So now let's try and let's look at what. So we are told that our W value is going to be the inverse of A times Z. So W is the inverse of A times Z. So what would that be? The inverse of A is minus 1 over 23 times what? Minus 7, 6, minus 2, 5. And the value of Z is what? 7 and minus 11. So I have 7 and minus 11. So what does that become? So that is pretty straightforward, and that becomes what? So let's start with that. So I have what? The multiplication. So here I have a 2 by 2 matrix, and here I have a 2 by 1 matrix. So the resulting matrix is going to be a 2 by 1 matrix, and the number of column here is equal to the number of row here, which is 2, 2, and the multiplication is possible. So W now is going to be what? Minus 1 over 23. So into bracket. So the first element, I'm going to multiply the first row by the column. So I have what? Minus 7 times 7. Then what? Plus 6 times minus 11. And the second row by here, I multiply the second row by the first column here. So I have what? Minus 2 times 7 plus 5 times minus 11. And what does that become? So my W value becomes minus 1 over 23 into bracket. Minus 7 times 7 gives me minus 49. And while 6 times 123 gives me minus 66. Minus 2 times 7 gives me minus 14. And 5 times minus 11 gives me minus 55. So what does that result in? So which is the same thing as what? Minus 1 over 23 into bracket. Minus 49 minus 66. That gives me minus 115. And minus 14 minus 55. That gives me minus 69. So I know that W value is the same thing as what? My X and my Y. X and my Y value. And that will be equal to, now I can bring this scalar inside by multiplying everything inside by this scalar quantity. So that is the same thing as having what? Minus 115 times minus 1 over 23, and bottom here becomes what? Minus 69 times minus 1 over 23. And when you do that, what does that result in? Minus times minus is plus, so I have 115 over 23. Here minus times minus is plus. I'm left with what? 69 over 23. So W, which is the same thing as what? X and Y, is equals to what? I have 115 over 23 and 69 over 23 is 3. So now I know that from here that the value of X is what? 115 over 23 and the value of Y is equals to what? 3. The question asks us to find the value of Y. So as you can see, the value of Y is 3. So the correct option to this question is option D, which is 3. So I should mention now that if you come across a question like this in which you are told to find the value of X or Y based on the matrix, you do not compulsorily need to solve it using matrix. Another way to do about it, if this might be too long or confusing for you, is to convert this to normal simultaneous equation. So this can also be written as what? 5x minus 6y is equals to 7, and this can be written as what? 2x minus 7y is equals to minus 11. Now you can use any method that you are familiar with to solve this, and you are still going to get your y value as 3. So this is one of the advantage of JAMB, in which you just have options. Nobody care about your workings, so you have to be smart. And in this case, if you don't know how to solve it using matrices, you can easily convert to normal form and solve it using either substitution or elimination method, and you are still going to get the same answer as what? Y being equals to 3. So this pretty much sums up what you need to know with regards to matrices for JAMB. Bye for now.